morning, class. So welcome to Industrial Electronics. Our topic for today is bounding and Schmitt Trigger. Okay. So bounding and Schmitt Trigger. So this will be our last topic for industrial for this subject. Okay. Okay, so let's start. Why is it bounding and Schmitt Trigger important? So example, so we have here this is a sinusoid. Okay. So with comparators, so if this is the input voltage for a comparator circuit, so a comparator circuit simply gives an output of either positive or negative values. So anong type to ng comparator, inverting or non-inverting? So based on the waveforms.
Inverting po.
Based on the waveforms, anong klaseng comparators yon?
Inverting po.
Okay, so you have an inverting comparators. Okay, why inverting? If you have positive input, you have negative output. So supposedly, so ideally, so if you have let's say if this is an inverting comparators, okay, positive, negative output. So it's like it's either you toggle from logic 0 to logic 1. But in real life, okay, this is what happens. Okay, so itong mga sinusoids na to, it represents noise. Okay, so ideally it should be a smooth sinusoid, di ba? Nakikita niyo naman to, di ba? When you had your experiments in electronics 1. So we're in sa sinusoid mismo merong mga spikes. Okay, so yung mga spikes na yan, it actually represents noise. So let's say this is a zero level. Okay, zero level comparator. So if you have noise here, okay, so let's say you have a high spike noise. Okay, every time the noise crosses the reference level, which is 0, so nagbabago yung, so the output voltage changes, or it toggles from one saturation point to another. Okay, so kagaya nito. So let's say you have it initially at positive output voltage. So there's a noise na to which crosses the 0 volts or reference level, 0 volts. So magbabago. Okay, so it toggles to 0. And then yung noise ulit crosses again the reference level. So it toggles again back to 1. Okay, so somewhere here it toggles again. It crosses the reference voltage. Okay, so it toggles again. So magbabago. And then around here it crosses again the 0 reference level, 0 volt reference level. So magbabago. So what do you think will happen to the output voltage? Okay, so as compared here, compare this one, slide number 1, slide number 2. So what can you say? Hello? Hindi nakikita screen ko? Hello? Can you see the PowerPoint?
Yes po.
Simon. How about Simon?
Tayo ba po akin din?
Why? Okay. Anyway, I will upload this in YouTube. So it depends on the internet connection. Okay. So some can see my PowerPoint, some cannot. Okay. So I will upload this later. Okay, so what can you say about the slide number 1 and slide number 2? So with slide number 1, so let's say you have an ideal input voltage wherein you have a smooth sinusoid. So we expect to have a smooth output. Okay, smooth din yung pagtagal from negative V out to positive V out. So you have a smooth output also, okay? And also it gives you an accurate output, okay? But with the presence of noise, so what can you say? What will happen to the output voltage? What can you say? So every time it crosses the reference voltage, so the output toggles back and forth. Okay, so in a way it gives a false output. Okay, false yung output niya kasi like this. You're already in the positive half cycle. Okay, so ideally the output should be negative. But because of the presence of noise, so it toggles back from, okay, so it toggles back from negative to positive, then back to negative, and so forth and so on. So it will give you a wrong information or wrong output voltage. Okay, so to address that issue, okay, so the Schmitt trigger, so it has it is devised to have a two reference voltage. So you have a positive VREF and negative VREF. So the difference between two VREFs, we call it as hysteresis voltage. Okay, so it's like a window. Okay, we're in so that the noise in the sinusoid along sinusoid will have a minimal effect to the uh, circuit. Okay, just like this one. So this is a Schmitt trigger. Okay, Schmitt trigger is, what can you say about Schmitt trigger? How does it differ from, let's say, inverting and non-inverting voltage? So what can you say about the circuit? Can you see the difference? What's the difference? What's the difference between Schmitt trigger and inverting and non-inverting circuit? So the circuits that we had discussed in our early days, early sessions, early lecture days, this sem. What's the difference? Can you spot the difference between the Schmitt trigger and the, let's say, inverting circuit?
Hindi align yung ano, ma'am, yung dalawang
Yes.
graph.
Hindi applied
Hindi align, ma'am.
ang aligned
Dalawang
ang
dalawang graph na nasa taas tsaka sa baba, ma'am.
okay. So the two resistances are connected where? Where is it connected? At the, where is it connected? Saan siya connected? Compared with at the,
Out.
okay,
Output.
positive, okay? At the positive input. Okay, so Schmitt trigger. So with Schmitt trigger, so as you can see, it looks like inverting and non-inverting, but take note that it is connected at the positive input. Okay, that's Schmitt trigger. So this is a positive feedback. Okay, so whereas inverting, non-inverting, so all those circuits that we had are all negative feedback. Okay, so Schmitt trigger is a positive feedback. Okay, so let's discuss. So with Schmitt trigger, so it allows us to have a positive reference voltage and negative reference voltage. Okay, so this is it. Okay, so we have here, okay, so UTP is R2. So again, the VREF is the reference voltage, is the voltage across R2 over R1 plus R2, as well as LTP. So you have a upper trip point and lower trip point. So the positive VREF now is coined as upper trip point and lower trip point. So is the hysteresis is the value between, so window voltage between positive VUTP and VLTP. Okay, so okay, so that's the Schmitt trigger. So I'll have an example later. Okay, let's proceed to bounding. Okay, so with bounding, Let's proceed to another topic, bounding. So I'll have the example for Schmitt Trigger, bounding, and comparators, okay, on the next session. For bounding, so we have bounding is process of limiting output range. So by the use of a Zener diode. So last time we have Zener diode. Zener diode can operate both in forward and reverse bias. If it is in forward bias, so again, so what is the voltage across Zener diode? Voltage across Zener diode if it is in forward bias.
0.7 po.
Okay. Yeah, that's better, no? Please, I feel like you're getting lost. Okay. So we have zero point 0.7. Okay. Okay, whereas if it is connected in reverse bias, so the voltage across Zener diode is equal to VZ, okay, Zener voltage, okay. So with bounding, so the circuit for bounding is just like the usual circuit. So it's just that your feedback is Zener diode, okay. So instead of resistor here, we have a Zener diode. So we have three variations for bounding, okay. So we have here a Zener diode connected this way, wherein the cathode is connected to V out and the anode connected to the inverting input. So let's see. Okay, consider positive half cycle for V in. So let's say you have a positive half cycle. Okay. So if this is the input positive half cycle, so what is the bias for Zener diode? Forward, reverse, glass.
Forward.
Okay, so we have forward bias. Okay, therefore the voltage across Zener is forward bias. So if it is forward bias, so therefore this is, where is the positive? At the anode, the cathode.
Ano?
Okay, the anode, cathode, and the voltage across Zener is, what is the voltage across Zener?
0.7.
Okay, 0.7 volts. Okay, so therefore, so this is equal to 0.7. Okay, so this is 0.7. Okay, and what would be the output voltage equal to? Okay, so imagine yourself, okay, measuring the output voltage here. You have the positive probe here and the negative probe here. So what do you think will you be able to measure? Ano mo measuring just sa V out? So this is the voltage across Zener. So you have 0.7, positive, negative. You may
Negative.
guess. Negative. That's right. Negative what? What's the value? Negative.
0.7.
Ah, yes. Thank you. Negative 0.7. Okay, so we'll be able to measure negative 0.7. So the value of this one is negative 0.7 volts. Okay, that's for positive half cycle. How about for negative half cycle? Okay, so we have no BRF here. Okay, so how about during negative half cycle? So again, so during positive half cycle, so the Zener is in forward bias, therefore the voltage across Zener is 0.7 volts. So we're in the positive is at anode and negative at cathode. Okay, so what will happen during negative half cycle? So we'll see. Okay, so we have here again, copy na natin to. Okay, so So you have negative 0.7 for positive half cycle. Okay. How about during negative half cycle? What do you think is the bias of the diode?
Forward.
Forward, negative half cycle.
Reverse.
Reverse bias.
Okay, reverse.
Reverse bias.
So this time the zener is in reverse bias. When we say reverse bias, the anode is connected at the, what is reverse bias means?
Positive
Class.
connected to cathode.
Reverse
Opposite.
is,
Opposite.
reverse
Sign.
is the anode is
Anode
connected to
is
the,
connected to the negative.
Negative.
okay, positive to negative, negative to positive. Forward bias is, okay, so this is a forward bias. So you have a positive half cycle. So you have a positive voltage as input, okay? Positive to positive. Okay, if you have positive to positive or negative to negative, that is already a forward bias. So this one, okay, so we have a negative input. So you have negative input, negative voltage input to the positive. So that's why it becomes reverse bias, okay? So if zener is connected in reverse bias, so what is the voltage across the diode? What is this equal to? Equal to,
Zener voltage.
okay, equal to Vz. Okay, so that is equal to Vz. That's correct. And what about the polarity? Where is the positive and where is the negative? If zener is in reverse bias, so therefore the positive is the
Cathode.
anode or cathode.
Cathode.
Okay, so the cathode becomes positive and the positive becomes the negative. Okay. Okay, so if that is so, so what would be the voltage across zener diode? So if we're going to have a VOM here, we're in the positive probe is at the V out, negative probe at the ground. So what do you think would be the output voltage?
PZ.
Okay, so equal to positive, negative VZ.
Positive. Positive.
Okay, yan. So equal to positive VZ, okay? So you have a positive VZ, and this one is negative, negative 0.7, okay? Okay. And of course, as it enters again the positive half cycle, so you will again be equal to zero point 0.7. So again, we'll have an output equal to 0.7. So therefore, with this circuit, okay, with this circuit, so the output is limited to positive VC and negative 0.7. Okay, so this is equal to VC. Question. That is for circuit number 1. Question for circuit number 1.
None.
None. How about the others? If you don't have microphone, you can type in here in meeting chat. Okay. Let's proceed. Okay, let's proceed. Where are we? Okay. So this is circuit number 1. Okay, so in bounding, it's just a matter of how to if you understand how the Zener diode works, okay, so it's a matter of how does the Zener diode reacts or responds, whether it's forward or reverse bias. So you will be able to should be able to draw the expected output waveform. So bounding, so it means that the output waveform is now restricted to zero point 0.7 and Zener voltage. Okay, so the output is dependent on the Zener voltage output. Okay. Whereas for comparators, okay, comparators wherein the output is from positive V out to negative V out. So you have a huge output. Okay. Okay, how about here? Circuit number 2. So as you can see, the zener now is reversed. Okay, so you have the cathode here, the anode here. Okay, so we'll see. Okay, negative half cycle. Okay, sorry. Positive half cycle. So if you have positive half cycle, so what do you think is the bias of Zener diode? Forward or reverse? What is the during positive half cycle? So the Zener here is forward or reverse bias. If you
Reverse.
have a positive input,
Reverse.
okay,
Reverse.
Zener is in
Reverse.
reverse bias. Okay, so
Bias.
Zener is in reverse bias. Therefore, the voltage across Zener diode is equal to, what is the voltage across Zener? Equal to, so if you have a reverse
VC.
bias, okay, equal to VC.
Busy.
Okay, which is,
Busy.
yes, equal to VZ or Zener voltage. Okay, wherein the positive is at cathode or anode. Where's the
Cathode.
positive? Okay, it becomes positive at cathode and negative at anode.
Anode.
Okay? Ayan. So the polarity becomes reverse if it is reverse bias. Okay? So therefore this is equal to VC. Okay? The voltage across is equal to VC. Okay? So therefore we have, what would be the output here? So we have equal to, it should be equal to VC. Okay. So Zener voltage, so it has rating. So let's say you want to buy 3 point something, 3.6, 5. Okay. So it definitely limits the output voltage to a certain level. Okay. By the way, what is the polarity of VC here? So if you're going to have your VOM and then measure the output voltage, so what are you going to measure across V out? Again,
Negative.
Negative.
negative VC. So it
Negative.
should be, so this should be negative VC. Okay. Oh, we're getting better. Okay. So this is negative VC. Okay. Okay, negative VC. Okay, for positive half cycle. Okay, so let's have it during this negative half cycle again. You have a negative half cycle. Okay, so what is the state of diode? What is the state of diode? Reverse forward bias.
Forward.
Forward.
Okay. So this time we have a forward bias. Okay. So forward bias. So therefore the voltage across Zener is equal to what?
0.7.
Okay, 0.7. So you have 0.7. So it's easy, no? 0.7. Okay, wherein the positive is equal to, so this is now equal to 0.7. Okay, and the positive is at, where do you place the positive? Anode, cathode.
Anode. Anode.
Okay.
Anode.
Okay, anode and cathode. Please don't be confused at the reversal of the polarity. Okay, it happens all the time. Okay. Okay, so since now if it is in forward bias, so the voltage across your diode is negative one. You have 0.7 voltage here, wherein the positive is at anode and negative at the cathode. Okay, so therefore, what is the V out? So if we're going to use VOM across V out, so what shall we measure? What?
Positive 0.7.
Okay, so we'll have positive. Okay, so this would be equal to positive zero point 0.7. Okay? Question class. Okay. I hope you don't get confused. Madali lang naman siya. Okay. So this is now the expected output waveform. Okay. So it means by just looking at the circuit alone, okay, you should be able to predict what would be the expected output waveform. So, ganito mangyayari, no? Sa comparators, bounding, and Schmitt Trigger. So, it's like, ipapredict mo na, yan, anong mag-itsura ng output waveform. Okay? Okay, and the last circuit, circuit number 3. Okay? Okay, so we now have two diodes, okay, back to back. Okay. So, ano kaya mangyayari dito? We'll see. Okay. Okay, so consider positive half cycle. So we now have positive half cycle. Okay, what is the state of D1 and what is the state of D2? D1, what is D1? If you have positive half cycle, what is D1 equal to? D1.
Reverse.
Okay, D1 is reverse bias.
Reverse.
Okay, reverse bias. While D2 is, what is D2?
Forward.
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 Po.
Okay. Okay, D1 is reverse, while D2 is forward. So therefore, what is the voltage across Zener? Across D1? What is the
VZ.
voltage? Okay, VZ.
VZ.
Okay, so this would be VZ. How about D2? How about
0.7.
okay,
0.7.
D2 would be 0.7. Okay, so we have 0.7 volts. Okay, so how about the polarity?
D1 positive.
Okay, okay, so we have we have positive. So where is the positive? Where is positive for D1 at anode or cathode?
Cathode po.
Okay, so we have positive at cathode and of course negative at anode. Okay, so we have plus minus. What's this? Okay, so this would be for D1. Okay. Okay, so we have we say for D1. Okay, how about for D2? So where is the positive for D2?
Anode.
Anode.
Okay, anode. Okay. And of course, negative would be at cathode.
Cathode.
Okay. So this would be so what do you think would be the total voltage total V out? So now you have two voltage. Okay. So what do you think would be the summation or the total V out? So what do you think?
Sira.
Or what will happen to BZ and point 7? Will they subtract or add?
Subtract.
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 Why subtract?
Ay, joke lang ma'am.
As you can see, they have the same flow, diba? Positive, negative, positive, negative. So, bakit subtractive? It should be additive, diba? Okay. With respect to V out, so it becomes equal to, with respect to V out, what would be our output?
Negative.
Negative. That's correct. Negative. Okay, konting push pa. Negative. Okay. Tama yun. Negative 0.7. Dalawa sila eh. Di ba?
1.4.
Negative. The VC here is not necessarily equal to 0.7, right? Yung visa, iba-ibang value yan. Pwedeng 3.6, pwedeng 10. Okay? It depends kung anong kailangan mong rating. Okay?
Negative 0.7 visa.
And negative 0.7 plus visa. Okay? So it's a combination of the visa and 0.7 voltage. Pero negative value. Tama ba? Kasi parehas yung negative, di ba? So it will just simply add up. But
Apo.
negative polarity. Tama ba, class?
Apo.
With respect here, okay, so you have two diodes. One exhibits VZ and the other one is equal to 0.7. So it's just simply equal to negative 0.7 plus negative VZ. Tama ba? Okay? Question. Okay. Question. Okay, none. Okay. Okay, so it's a combination of 0.7 and VZ pero negative voltage. Okay, so the answer here is negative VZ plus 0.7. Negative value. Okay? Ano ba to? Niwahiwalay ko pala. D1 is VZ. Okay. So positive pa lang pala to. This is VZ and D2 is, ano ba to? 0.7. For a total of negative VZ plus 0.7 volts. Okay? How about consider now negative half cycle. Okay, considering negative half cycle. So again, negative half cycle. Now we're in negative half cycle. Okay. So D1 now, if you have negative half cycle, negative input, so what is the state of D1 and D2? D1 is?
Forward.
Okay, D1 now is forward. Okay. Whereas is?
Reverse.
Okay, reverse. Forward because negative to negative. Okay. D2 is reverse because negative to positive. Okay. Please ask questions, no? If you want any clarifications, no? Okay. You understand? Okay. Forward bias. So, naintindihan niyo na ba to? Kailan forward bias ang Zener? Kailan siya reverse? Any question about that? Class? Okay na?
Okay po.
Edeline. Any question, Edeline? When does the Zener becomes forward bias and when it becomes reverse bias? Edeline?
Wala po, ma'am.
Anong wala? Wala kang naintindihan o wala kang tanong?
Wala akong tanong, ma'am.
Talaga?
Yes po.
Cassie. Question, Cassie.
Wala po, ma'am.
Anong wala?
Wala po akong tanong.
Okay, so last slide na natin to. Okay. Therefore, the voltage across D1, since D1 is in forward bias, so what is the voltage across D1?
0.7.
Okay, so equal to 0.7. So this is equal to 0.7. Okay. And the voltage across D2 is equal to, so D2 is in
VZ.
reverse bias. Therefore, the voltage across D2 is equal to, okay, equal to VZ. Okay, very good. Okay. Yan. No, electronics sounds simple, no? Simple lang naman talaga siya. So, electronics actually is foundation of electronics is a matter of when to know when it is reverse or forward bias. Yun lang. Okay. So, that's the basic. Okay. That's why I'm stressing it out to you. Okay. So, when the time comes, okay, so you will in an interview, so you will be asked repeatedly Okay, wherein the answers hangs on whether it is forward or reverse bias. Okay. Okay, voltage across D1.7 whereas the voltage across D2 is VZ. Okay. So just like here. Okay. So we have VZ for what's this? D2. Okay. And for D1, so again it is equal to 0.7. Am I right? Okay, and then we have ano pa ba? So the placement of positive and negative. Okay. Okay, so we have positive. Saan natin ilalagay yung positive kay D1? At anode, cathode. D1.
Anode po.
Okay, anode. Okay, so we have anode here. And then, of course, the negative is at cathode. Okay. And then, how about for D2? Where is the positive? For D2, where is the positive?
Cathode.
Okay, so the positive is placed at cathode. Okay. Whereas negative is placed at anode. Okay, at least. I hope everything's clear. Okay. Okay. That's it. So we have negative positive 0.7 for D1 and negative positive VZ for D2. Okay. So therefore, what is the total voltage? If you're going to have a VOM across V out, okay, so what do you think will be the measurement across V out?
Positive 0.7 plus BZ volts.
Okay, so we'll have the same output as this one. It's just that it is a positive value. Okay, so same output. Okay. Okay, so therefore, again, if you have positive output, okay, so this will be our output. Okay, so if you have a configuration like this, so you'll have a square wave pa rin, no? With both amplitude for positive and negative. Okay. Question. So next week we still have more we'll have example for comparators, bounding, and Schmitt Trigger. Okay. And I guess we need to have a quiz unit exam number 2. But I think I have to limit it. What do you think? We'll have to limit it to differential. We start from differential to instrumentation, integrator, differentiator, and up until instrumentation amplifier. Would that be all right, class? Okay. Bagal daw data kay Alex. Kala ko nagtitiktok Alex eh. We're going to have unit exam number 2 next week. Okay? The coverage are from differential amplifier. Of course, included also yung inverting, non-inverting because basic yan, basic and summing. Okay. So, may or may not be included, but it doesn't hurt to study also. Okay, kasi basic yon. And then, differential amplifiers, ano pa? Instrumentation, up until instrumentation, integrator, differentiator. So, those are the major topics. Okay? Comparators, bounding, Schmitt trigger not included in unit exam number 2. We'll have it next week. Question.
What time po, ma'am? Same time po.
Thursday morning. Parang. Thursday morning, we'll have unit exam number 2. Sino pa hindi nakapag-upload na ano nyo, poster? Gawa lang kayo tapos upload nyo sa BN ha.
Yes.
Ba't parang ang lungkot
Yes, ma'am.
nyo? Last time may music pa. Gusto ko yung may music ha. Question. None? Concern. Concerns about your online studies. Okay naman kayo sa ibang yung mga teachers, sa lahat ng teachers? Don't have any concerns? Puro major naman na kayo no? Dapat ngayon pa lang you should be able to mag-start na kayo ng technical research. Okay? So, dapat nag-start na kayong magbasa-basa ng ano yung possible yung parang project study. You also have project study. Project development ang tawag niya. Okay, may project din kayo. Question. Napaka-fitness nyo ngayon. Could it be the weather? Maulan ba dyan? Okay, so we have 27. So actually, I have fairly a lot of attendees, for this subject, So if you have no more questions, so that's all for now. Okay, thank you for attending my class and stay safe. Ayan, pataas ng pataas yung COVID natin, It's alarming. Ayan, stay safe and bye everyone.